All right, what's up, everybody? How are you doing? So, we're here this wonderful Saturday afternoon. Thank you, Peter Yield. I appreciate that. Definitely let me know if levels get jacked or anything like that. So, I've posted the new streaming schedule for those of you who like to check out the Discord. You can, I think I have it in the show notes today. I actually went with the right show notes today. Yeah, okay, cool, yeah. Bots got there. So you can drop by there. I post the schedule 3 times a week. Let's see, Tuesday, Wednesday, and Saturday was the winning votes off the top of my head. Anyway, you can hang out there. You can talk about programming. You can get the latest updates. So I got something, that guess the cart. No one guessed it right. I thought Paul, I thought you were in there. So I'm going to show you guys the hint if you take a very close look. So and by close look, I mean let's take a really close look. Let's get right in there and have a look see. Okay, you can't really see that well. But we have a light. Let's turn the light on. Okay, so we're going to blast that away, and we're going to focus. And that's your hint right there. So NES ZL-0 Prog. Okay, so this is the program ROM. This is an EEPROM chip, and that ZL is it. ZL. This is a Zelda cartridge. Okay, so just in case you were wondering, that's actually what was there in the start of the show. So I'm going to not make Zelda. Zelda is a fantastic game. I loved it. I couldn't believe how much they got out of these chips, especially with the memory mapper that's on there. FIFA, nice. But they really did get a lot out of the hardware for that era. That's kind of amazing. We are being way more wasteful. We're writing in C on the NES, and we're just throwing away memory because we want to get this cart done as quick as possible. I do want it to fit roughly on the same type of chips, like in terms of the same NROM configuration. So we'll be playing a bit with that as we go. So let me just pull up, let's grab our coding screen. So I just checked Messin there, it was working fine. And the current layout that I've got, this is an NROM 256 with vertical mirroring configuration. So this is a pretty minimal chip, and it'll lay out fine on the parts that I was able to source. So that's these that I showed in a previous show. This is the 27C256. So I'll have to copy it. There's some aliasing issues with memory and some whatever, but we should be all right with this memory layout on the chip. So yeah, you were totally points for being totally close, Paul Blart. FIFA 2002, Zelda, they're like basically exactly the same thing. All right, so what I wanted to do today was Erholzenblatt. Guten Abend. Actually, I guess it's Guten Morgen. Oh no, it's Guten Abend. Okay. Oh darn, unfortunately I cannot stay for long, but here we go. Yep. Hello to you too. Just still having the coffee myself. We're in that part of the day. I guess this is probably a pretty reasonable time zone. So we're sort of scattered between 2 night sessions and an afternoon session. So I'm guessing people overseas are probably going to grab this session more than some of the other ones. Good, it is Guten Abend. Okay, I've forgotten most of my German, so we'll worry about that later. But right, so let's pick up where we left off. So where we left off was we were hacking around on levels, and I had we were looking around in memory a little bit, and we found our Cafe Dude memory. And this was while we were debugging. We were working on collision detection for the lower right corner. So rather than I didn't have time to mop up the other directions. I want to sort of like generalize some of that code so that we don't have to repeat it like 8 million times. So I'm going to save some of that for off stream. I thought we would do something a little more fun today, which was, thanks. Thank you. Appreciate that. So what I had was, it was very hard to see what the values were. I mean, debugging is tricky because it's in a separate window. We're sort of peeking into the memory map of the 6502 emulation for the NES, and that works. It's a pretty advanced technique. For sort of simpler, like when we're kind of just targeting a single variable, it might be a lot nicer to do it on screen. And a common technique that gets used is, so what I want to do today is kind of like, let's add a high score field. Okay, it's not really a high score field because we're going to use it mostly for debugging, but we are going to need a score field anyway in the final product. So I figure we need to count bits that are collected. So that seems like a pretty decent thing to implement, and if we implement it early, we can use it. We can cross use it for debugging. So let's get let's get messing running here. So I'm just going to do a quick make run, and all right, so we're getting our Bitboi Classic is popping up, and that's all cool. And let's so where we got to last time, we were sort of pinning the user up here in kind of the top right, and here's our player sort of chilling out up here, and we were dealing with this side interaction on the bottom of the tile. So as I get the full character on the screen, this character cannot move when that bottom right corner hits the tile. So that's pretty cool in terms of so when we're doing this sort of thing, yeah, he can come up to the stair, and then he can come here, and then so on. But so that works pretty well. I just need to generalize that technique. So we need to add things like not letting him go through the side of the level like you just saw there. And we need to add, where we're going with that is we're going to add jump physics next. So as soon as we know how to collide things, then we can start working with controls that are a little more fun. So what I want to do now is let's go up here in this top right corner and add a display. So we're not going to go for an arbitrary debug display. We're just going to go for kind of a simple, time sort of thing. So let's warm up with that. So I'm not too worried about burning a sprite up here because, as you might or might not know from the earlier session, you can only get so many sprites in one horizontal line. And this is pretty close to the limit here. We've got 2 for our character. Each of these tiles counts as a sprite. So you got 2 here for one of the enemies. You got 2 here for the other enemy. And we needed to reserve 1 for our firing, our note firing shot. So that's pretty close to the limit, especially if you're going to have one other sprite for collision or something like that. So, but up here on the top of the screen, this is going to be kind of out of the play field for our general character. We can either use the top or the bottom, I'm not really sure, but regardless, it's going to be an area where sprites aren't generally active. So I'm okay using a sprite for the counter, and then we don't have to do some of the crazy techniques because these tiles that you see in the background, painting on the background is a little different. You have to kind of do it when the scan line comes down and it hits the bottom here of the screen. You have this little interval, which is called the V blank interval, and that's your only time that you can sort of update all of these, the name table, which is basically the background in my case. If you try to update it in the middle of the screen, typically you'll glitch unless you're very careful with your cycle timing and you manage to race the beam. So as the beam is scanning across, you pop it so that the memory transfer happens before the beam gets there, you're okay, and then you pop it back, and then you can cheat your way to some more drawing time rather than just V blank. But since our game is relatively simple, there's not too many moving objects, then we should be all right doing our memory copies in the V blank interval. But regardless, let's not add complexity. So that's why I'm thinking the simpler thing to do is probably the sprite. So let's start by just drawing a sprite on the screen up at the top and see sort of what happens. So the enemies right now, they're sprites. So this is kind of our existing, this is our X, our Y, and which tile we're using, or I forget what we put there. And then this is enemy number 2. This is the X and the Y and what have you. So that's fine. And then we're using that in sort of this add enemy routine. So those are turning into sprite calls, and that's what's happening with this OAM when we're hitting the OAM hardware. So this is the Bitboi draw. So you can see that there's 6 lines because I'm drawing the top 2 sprites, and then I'm drawing across, and then I'm drawing the next 2 sprites, and then I'm drawing the next 2 sprites. So I should be able to just sort of sneak in another sprite. Now I got to be careful about this sprite position. So sprite starts off at 0. This is which sprite we're going to be messing with in the table. And so before we increment the frame, probably at the end of the frame, this is a decent place to go mess around. So here I'm moving forward the note as it's firing across the screen. And Miser, hello, nice to see you. So we'll try the naive thing first. Okay, so that means that basically we're going to take something, and we need something that's going to represent eventually our numbers. So let's actually, you know what? We're going to have too many numbers in a row, aren't we? So we're going to end up overwriting all sorts of sprite stuff. Okay, so I think that complexity I said I was trying to avoid, I think we're going to be on the name table anyway. What is that IDE? That is Vim. I guess it's not very I, but it is very DE. So this is Vim, just raw command line stuff. I'm running it in screen, so that's what you have over here. And yeah, I'm using CC65, which you can see the result of the last build over here. These are kind of my build steps. So CA65 is the assembler, CC65 is the C compiler, then that's assembled, and then this is the linker, is LD65. Messin is the NES emulator that I'm using today. Can I work with Vim in Win 10? Vim is available everywhere, and even if you don't use Vim itself, you can use Vim key bindings just about everywhere. So like I don't want to say all, but a lot of major IDEs actually support Vim movement, and that's a very efficient way to kind of move around on the screen. So Vim movement is probably more important than Vim itself. But again, that kind of depends on what sort of development environment you're working in. Twitch IRC is so borked. 2126 Ursi joined to SomeCodingGuy with Saints. Oh wow. So we might have a little bit of fun then with chat. Okay, so all right, let's just start off and continue to be naive for the moment. The other thing that we can do is we can start upload. I mean, if we're going to mess around with the name table, well, I'll get into that if we need to get into that. So let's just start off with just a basic position. So we're going to drop a block at like 0, 0, and we can borrow this because we know this is the musical note, and I think that's messing around with the palette, and this is the current sprite that we're writing to the OAM table. All right, so if we start off there, and we make that, yep, cool, and we make run it, then yeah, okay, here's our musical note that we just placed manually. Now, not too worried. Well, we should probably torture test this a little bit just because yeah, so we're all right with the draw there. And when I fire, we're still okay down here. So let's just run a few of these to see where we're going to blow this up. So we're going to take these and we're going to just offset them by 8 apiece. And we're going to, actually, you know what, let's shift this all over to like 160. And this will be like 168, and this will be like 176. Okay, so we're gonna draw that stuff on OAM. Okay, so here's our 3 musical notes. Everything is still showing up in the scene, so we seem to be all right. Okay, so we're not breaking the rule of too many sprites in a line, but I have a feeling we're getting near that limit. All right, so we'll just toss this. We'll make it. Yeah, okay, so everything seems to be showing up. All right, nice. Hey, what's up, Cam? Oh, Cam, throwing the bit lurk. Nice. That was Cam dropped by 88-bit keys the other night, and it's kind of a fun experience if you like video game music. So when I try to download Vim, my browser blocks because it says that Vim could damage my PC. Should I unblock? I mean, so it's an install program. He's trying out Windows Vim. And arrows and plots, yeah, he's probably getting the browser message that says this type of file can be harmful because it's like an exe or an MSI or something. And why are you using browsers down? Oh, come on, it's fine, Cam. They said, yeah, using Win 10. Watched him several hours. It's great. Yeah, he's 88-bit keys totally is great. Yeah, so that. We're not going to be able to do like a full Vim installation help tutorial today. I mean, we've got some NES stuff to write, Miser, but it's good spirit though. Okay, so right. Well, now we can start actually mapping ourselves a few numbers. By the way, if you're really interested, oh, and hey, what's up, 715209? Miser, so if you're really interested too, I also do learning streams on Tuesday nights. So, we have a little more time to kind of work in the chat session there. Sword fight, nice. I mean, I can't tell you what you want to do with your computer. If you think it's safe to install Vim, then that's your determination. There's all sorts of license stuff in there when you agree to this. Now, it's not... Vim is a very old program, but I mean, I don't know which build you're taking, and you need to manage your own computer. I can't tell you what to do with it. All right, so I was just going to take a quick look at the PPU. So the PPU is the graphics chip in the Nintendo, and you can see this is our sprite. This is our name table that we can use for graphics. And we're kind of interested in this line here for numbers, for numeric output. So this is tile index 30. So let's try switching this over to and I think this is in hex. I want to say this is in hex. Yeah, it is in hex. Okay, so this is like 30, 31, 32, 33. All right, so we will close this and run it again. Wow, that's a serious sword you got there, 715209. Okay. Okay, so we got some numeric output. Hey, cool. If everything was that simple. So that's good to know. Let's actually link these numbers up to do something, just so that we can make sure that we're kind of updating it right. And I think for now, let's take... I don't actually need to have this in here at all. So we can go crazy and move this into a function. So I think that, by the way, I should warn you, Miser, Vim has a very hefty learning curve. So you're going to be doing a lot of work to master Vim. Just to warn you, its movement is amazing, but I'm just telling you that it is not a simple learning curve. Just to warn you. the advantage of it is that you can move through your text editor, which if you're programming, I mean, you live and die by your text editor. So you want to, you know, have awesome movement, but I mean, like it's difficult. I'm scared with that. Just install vim.exe file, appears on GitHub. Yeah, you can download a Vim extension for yeah, that's actually probably a better place to start, as Cam is saying right now, because that way you can start learning Vim key movement without actually, you don't have to worry about running Vim and doing all the integration stuff that you have to do. If you're using Visual Studio Code, then like I was saying, Vim movement is far more important than using Vim. So, although personally I like Vim. So let's say that this is our display number. So this will be our display. It's actually a high score. Display score. It's not a high score. And it's going to take a, we'll pass a whole int. So this will be that. And we need to know the current sprite, which I want to say is an unsigned char. Yeah. Yeah, cool. No, it's global. I don't have to pass it. Okay, right. So let's go back up here and not pass it. And okay, so that's the current sprite, moving through the hardware, and wonderful things happen. So let's just display score down here. And we'll give it like one, well, let's give it something different. 321. Score is never used. Yeah, that's all right. What's my undefined symbol SPR? Did I define it after? Yeah, I totally did. All right, so we're gonna just move this down. I need to reorganize these files. I've been live coding too much, so you got to pay down that code debt regularly from live coding. Okay. So our number still shows up. That's cool. Now we actually have to make it display the right number. So we need to do a little bit of math here, which yes, someone 5 says Vim movements are pretty awesome. I didn't have a good experience with using Vim on Windows, kind of shady. I mean, it is more common in a Unix environment, Miser, I should say. I'm using PyCharm. I will Google about Vim extension for PyCharm. Okay. I haven't used PyCharm IDE, but PyCharm probably, knowing the community it comes from, they probably have Vim bindings like built in. You just have to like turn it on. So give that a look. Okay, so we need to start using score. And the way we're going to do this is we need to read this number. I mean, we're basically doing the equivalent of like a printf here, right? So we need to, so say we get score is like, you know, 321. Then what we need to do is we need to pull, we need to make a decision about our maximum score, but for now I'm just going to assume that we're going for 4 digits. So we need to pull a digit. So let's go with a full comment here. We need to pull a digit off, display it, and just really get the last digit, display it, remove the digit and repeat. Okay, so it looks kind of like that. So what we're going to do is let's give ourselves a counter. And let's say for I is 0 and I is, we're going to just pull 4 digits. And let's increment that. We don't even really need the loop. I mean, it's sort of few enough that we just unroll it right now. Oh, Quadrin, hello. Haven't seen you around here before. Welcome. This is really cool. Can you explain what's going on here? Cam, do you happen to have that link handy? I don't remember. We really got to get a bot command for that link. I'm basically building a Nintendo game for another person on Twitch, another Twitcher. And it's an old school Nintendo game that we're actually going to throw onto a cartridge. This is totally my fault. This is exactly why you put like your current project as like an exclamation point command, like a bot command, so that's like people who come in, they can easily see what you're what you're doing. Oh, and Miser, thanks for the follow. I appreciate it. Yeah, it is totally cool. This is actually a this is a donor cartridge that I took a really crappy game, and trust me, it's really crappy. And I pulled the EEPROMs off it, and actually they're PROMs because they're actually just burned in mask ROM. And I'm going to mount my own on here after we finish getting this game to work in the emulator. So, and then we're going to put this back into the cartridge shell that I took it from. and then we're going to ship it. So thank you, Cam. I appreciate it. Let me get that bot command. Do you mind if we just aside and make life easy for people who come in, and Cam? Let's just quickly add that to the bot. So I've got, let's see, this is some bot. I coded the bot on stream too a long time ago. So this is going to be a static command. And do I already have NES in here? I feel like there is an NES command. Let's just add on to that. Actually, let's add a new command for Bitboi. So Bitboi, and we'll accept Bitboi Classic or NES game, and we'll say that this is building an NES game for 88-bit music, talking about the 88-bit music. All right, so we're building it for 88-bit music, and this is the clip. All right, so if we go and do that and reset the bot, then we should have Bitboi. Hey, all right, cool. And thank you for digging that up, Cam. No, I haven't added a commands command. I don't know. I didn't actually check if it's the right clip. Yeah, what is Bitboi Classic? That's totally the right clip. You picked the right one. Have you programmed other systems as well? Quadrin, like all the systems. I love programming. I've been programming for ages. I generally don't work on NES games, so this is not my typical coding. I've done very little actual NES coding, but I have done a lot of 6502 back in the day, more on 68K. 6502 was pretty locked up back then, so it was pretty hard. Atari 2600 actually uses the same processor as the NES. The biggest difference is it's different stepping, but it's a very different graphics chip. You know, the graphics chip that's in the 2600 is like, I think programmers from that era just all have PTSD talking about that graphics chip. But It's the television interface adapter, the TIA adapter. The PPU on the Nintendo is like, you're downright spoiled with a graphics processor, which you'll hear me curse plenty about the PPU while we're working with it, but like it's downright spoiling compared to the experience on a TIA. Yeah, small data is, I'm totally, what? I'm showing you all the commands. We can't have the commands. The small data sets are actually, that's from the Learn sessions, Cam. I built those for anybody who wanted to follow along with the Learn stuff and do the exercises on their own. I figured I'd include the data sets that we use. Oh God, that command reminds me that I wanted to implement that in my fork of Zoding's Haskell bot. He wrote his bot in Haskell? Wow. It's going to be a lot of fun. I don't know Zoding, but I feel like I need to get to know him. Speaking of Haskell, functional programming is pretty cool. All right, let's not start any functional programming fights in here, 715. I thought you were around for some of the rants I did on functional programming, but let me just say that functional programming, I'm not actually opposed to functional programming. I am opposed to, I have never seen it go well in a corporate environment. Let me just say that. I've seen a lot of confused programmers and a lot of pretty damaged, brain dead code as a result of trying to make things functional when they really weren't. And anyway, I don't want to get into that. Luckily, I am too new to know what functional programming is. Cam, it's kind of a programming philosophy. Okay, like functional. This is really a long discussion, but functional programming is so. I don't really know where to start this lecture, but it kind of begins with the lambda calculus. So it's this notion of a so let's forget about terminology because that's going to just, one of the issues I have with functional programming is they borrow a lot of terminology from mathematics and they sometimes misuse it and they generally make it inaccessible to everyone, and I don't like that. The goal with functional programming is to build side effect free code, and the way you do that is kind of you write something and you perform sort of a series of transformations on it from your input to your output domain, and they're all kind of contained. And there's you end up in functional programming passing functions around a lot. You treat functions typically as variables. This is the kind of lambda calculus. And one of the nice side effects of that is it's formally provable. So if you care about proving correctness, then this is kind of an interesting way to go. It also has some nice language features that promote things like parallelism, threading, a lot of fairly advanced concepts that are hard to express in classic, classic languages that are more iterative. They say that it's more declarative as a language. But anyway, I don't want to get into like terminology like discussions. Like I'm not. There's some great functional programming tutorials. Some languages like Haskell are really built around functional programming, so like it's really hard not to to be a functional programmer in those languages. I think that's about as good as I can do in a short summary of kind of what it is. Everything is typically connected together through composition. So you're usually like, I just said I'm not going to use terminology. I just dropped terminology. I'm very sorry. The idea is that like you take like a function and you pass it another function, and then the result gets consumed by another function, and then the result gets consumed by another function. You end up with this really big functional chain, which, by the way, depending on the tool set and language you're working in, can be very, very difficult to debug. And it can be hell on hardware. Now, some of the hardcore functional programmers love to declare that the real problem here is that the languages and pattern idioms that we use are all based on the von Neumann architecture of CPUs winning. And for those of you who don't know what the von Neumann architecture is, it's basically every processor in existence. So there's a reason we don't typically call them von Neumann architecture processors anymore, because they're all like such. Okay, so yeah, function composition is a very large part of it, Cam. It's not enough, like it's not sufficient to say that if you're just composing functions, you're functionally programming, but it probably helps if I did some of this by example, but I really don't want to get into a functional programming stream. Speaking of lambda calculus, lambda calculus is really the mathematical basis for functional programming. So there's certain languages that are very strong on the lambda calculus. And then there's certain languages that purport to be strong on the lambda calculus. JavaScript. But anyway, there's other places where it makes sense. So I won't get into that. But yeah, that's what Eralts and Plotz is saying. That is definitely what functional composition is. And it has different terminology. You could say G in this case, he's doing f of g of x, which is f follows g of x. I think if I'm remembering the right terminology. It is, well, I mean, like all languages, it's like Rust. I mean, it's not that it's a bad idea, but it definitely is a community. So, and they have definite thoughts about everybody else's programming, and they typically start these fights. But the ones who are really like kind of great at functional programming, they just use it because it tends to make things more bug-free and easier to parallelize. So there are like nice features of it, but that's typically not what you're going to hear about. Anybody who knows what lambda calculus is, though, they're probably on the good side of functional programming. Dennis even built the thing on, yeah. So you can already see like the LC interpreter. Yeah, this is kind of the good side of FP. So I shouldn't get too politically involved at my Hello World. Actually, the funny joke that I always had with, I used to go to the functional programming lunch meetup at Netflix, and one of the funny jokes that we would share was, one of the goals of functional programming is to be side effect free, and Hello World is having output, which by definition is a side effect. The output is a side effect. So like when you're talking about like console output for like, stdio, and so it already is not, it's like logging. Logging is not functional sort of by nature because it is a side effect of the execution. Anyway, tried looking it up once, never found a good explanation. I could go dig around if we want to do like a little section on functional programming at some point. There's probably other streamers that are way more into it than I am. Runs around in large circle. Haha, Okigan. Ha. Yeah, it's an interesting time you just bumped in, Okigan. Time ceases to exist for you. Yeah. Okay, we're going back to the NES, and if you try to program an NES with a functional programming language, you're never even going to get through like a stack frame. I shouldn't say that. I mean, somebody did do a Lisp interpreter on NES once, and Lisp is sort of a lambda calculus type language. It's, I mean, all the small talk derivatives, modula, like you can get them to work efficiently on these type of modern processors, but by the way, the IO is just a function transforming the outside world that makes side effects pure. Okay, all right. Yeah, I mean, you can play games with, I mean, like, as I like to point out, like they've done a lot of work with like trying to be functional programming for games, and like the screen is very much a side effect. Like pixels drawn and left are very side effect heavy. I won't worry about it until I learn what lambda calculus is. I mean, that's probably the right way to proceed with FP. I mean, if you want to get like a taste of FP, there's some like lighter JavaScript type intros for functional programming, but anyway, is 6502 assembly language applicable anywhere in the modern world? Like 6502 is kind of a classic chip that, it has a lot of love even in modern projects, but I I don't know of any new stuff that's generally using 6502. The techniques that you learn with 6502 assembly language absolutely are still applicable. And that I do some sessions on RISC-V, which is a much newer ISA, but instruction set architecture. But the advantage of using something like RISC-V instead of continuing with something like 6502 is that RISC-V not only has it been built around some more modern primitives like multi-core systems and stuff like that, but it also is totally free and totally open source. It's not like 6502 is owned by MOS, which I don't even know who owns MOS at this point. So you're talking about a licensed core. So if you had a choice between doing like a 6502 core in a modern project and a RISC-V core, why would you choose the 6502 core, unless your application was like to do a Nintendo emulator or something like that? It is great as an intro to assembly, and I love it from a learning angle because 6502, like Cam says, it's really nice instruction. It's not, there's not too much there, and it's very readable. Or maybe I'm kidding myself, I don't know. But this CC65 actually will dump out the 6502 assembly that happens. So you can forget about the memory bytes. That's my variables. But this is actually the assembly down here. So, you got your jump subroutine. You've only got one real register you have to worry about aside from the index register. So this is load the accumulator with 0. So that's just loading 0 into the accumulator. Jump subroutine to push A. So wherever push A is, this is going to go there, and it's a function call, and then it's going to come back. I feel like this is really readable, like load X, like this is immediate addressing mode. So there's no assembly that's simple, but like this I feel like is kind of as good as it gets in terms of like lower level simplicity. I mean, like here you got a load A, you have two index registers, you have an X and a Y register, so these load instructions are there. This is store, so loads and stores are your basic, any architecture, you're loading and storing a lot. And so you're storing the accumulator somewhere, and this is a indexed offset. This is a little more complicated. Here's a compare, load accumulator. All right, so I mean, like this isn't bad to read. Like, and it's back in the day when you had to hand assemble it, it wasn't too bad to hand assemble, relatively speaking. And and RISC-V is great, but RISC-V, you don't really need to worry about the assembly because they have modern GCC plugged into RISC-V. So, and it's very good at optimizing. So, like you don't need to worry. It's like, I don't know how. I've never thought about this for like a learn session. Like, is it better to teach 6502 first and then upgrade to RISC-V, or teach RISC-V assembly, or never get into RISC-V assembly and let the compiler deal with it? And like this is kind of nice because on a 6502 it's just a much simpler architecture. I mean, RISC-V assembly is not that bad to look at, but yeah, sorry if that's kind of a long answer to your question. It's 6502 is great for learning, I'll tell you that. Okay, got to go. Have a good time, good night, whatever time it is for you. Good night, arrows and plots. RISC-V, by the way. Yep, that's the right spelling. So what is the best resource to learn RISC-V? That's a good question, Quadrant. I don't know. I mean, so RISC-V is published by the Berkeley BSD, but they're not called BSD anymore. Berkeley School, University of California, Berkeley, Cal, right? They publish the instruction set architecture. That's not the way to learn it. I mean, that's like a deep dive into the assembly and why they made the choices they did for this type of assembly and all of the opcodes. Like you don't want like a reference of every single opcode to learn it. You want like a learning guide. That's something that I want to get to. Like earlier in the show, I started doing this. Oh, don't look. It's the new website, everybody. Don't look at it. Okay, so it's not quite ready. So if we go here and we look at the show, which this is the show, there's the show. I covered RISC-V in episode 5. But this is not a good learning resource. So I plan on coming back to this and probably developing a Learn course around it. This is a JavaScript 6502 decoder. So that my goal was to eventually build some web tools as learning resources, so to try to make it a little more accessible for people getting into RISC-V. And there's some other stuff that I want to do with this later. But yeah, my eyes are closed. I found this one. Udemy is teaching programming games for the Atari 2600. Nice. 2600's hard. I mean, the NES is hard, but the 2600's even harder. So I would probably not do that. There's more resources available for, but who knows? I mean, if they have a whole course together, maybe they've figured out like some good materials for that. So do you think this is a decent resource? Yeah, I mean, I haven't used it myself, but I mean, if they put together a full course, then maybe it's good. I don't know. I mean, I don't know if anybody in chat has seen this particular Udemy course that they could comment on it. I don't know. Part of it is RISC-V is kind of new enough that there's not a lot of learning resources that aren't like just university courses. I know that there's a bunch of university courses, but I feel like for like just playing around and getting a sense, like I think it's still a little bit thin. Good reviews overall. Okay, the guy that teaches this is pretty smart so far. Look through his calendar. Okay, well then maybe he put together a good course already. I still plan on doing some other coursework, but I'm not there yet. So anyway, okay, so right. We're aside from the aside. Am I on YouTube? Yes, I am. I am actually working on that as part of upgrading this website because I've been doing a lot more Twitch and not doing much YouTube. And so I'm going to be figuring out a way to like get more of my videos from Twitch over to YouTube and vice versa. I don't know. I might try it YouTube live soon. So anyway, don't worry, I'm not disappearing. Just saying I also want to try that out. Just curious. Okay, so the naive implementation of this is we take score and we mod it by 10. So this is basically the last digit, right? From a decimal standpoint, the last digit would be 10. I know that this is expensive on a 6502. I'm not worried about speed right now. So if I take that, this is the current digit. So let's go and make that a variable. So let's say that's unsigned care current digit. And let's take current digit. It's the mod 10 of score. And then score gets score divided by 10. So that'll chop the digit off. So what I'm doing is I'm taking the last digit and I'm also chopping it off and I'm storing it in score. And then I can just move this ahead. So this will be my right. And then I just need to keep my position right. And the way I do that is I start at the last one, which is this one, and I write out the last digit, and then I'm just going to kind of like move forward and write the digits out. So you know what? I am going to take this as a loop because I think that might even save us some trouble. So we'll say for I equals 0 and I is less than 4, increment I, and we do that. So this will just keep overwriting the same location. So what I need to do is I need to subtract 8 times I. And sorry. And this is the number that I'm going to need to add. So this is the 0 character, and I'm going to add to it whatever the current digit is. So let's see how that goes. Current level. I don't want current level, I want current digit. Where did I forget? Aha, no. Okay, so that comes here. 321. Wait, tell me that just worked on the first try. Come on, that's not possible. That what? No. All right. So okay, display score 321, 322. 322. Okay. So that's awkward. I thought that was going to take a while. Right. Anyway, let's go look at chat. So one of the benefits of not becoming a Twitch partner is that you can stream on both platforms at the same time. Interesting. I didn't know that, Cam. I mean, I'm some Twitch affiliate. For those of you that are new here, I'm the low-level peon of Twitch. Several of the people I watch have a chat aggregator, so all chat is in one place. That's interesting. What about these books? Risk 5, Learn the... I haven't read them. I mean, I read the instruction set architecture manual, so I came in it from that perspective quadrant. So I can't really comment. I have to like do some serious review. I'll take some of these links down because, I mean, there seems to be a lot of interest. I definitely want to do a learn session around Risk 5 stuff. So, I mean, it's on the official Risk 5 website, so at least it's not full of wrong information. But okay, yeah. So there's a comp.org book. Yeah, I mean, these are the right people. So I can't really, I mean, I have to read it, right? So I have a feeling that there's probably an open source one. I don't know. I don't know what's available for free, but I mean, this isn't, these are certainly the right people. So yeah, less time. Yeah, I mean, that's, yeah, I hear you, Quadrant. So that's why, like, all the educational materials that I build are free. But not to belittle their work. I'm sure that's probably some high quality textbook stuff. But I mean, like, anyway, I'm not going to get into my stance on education. I want this stuff to be freely accessible for people that are interested. Yeah, hands-on self-learning. That's cool. Well, Quadrant, if you do try it out, then, you know, come back, join the Discord and let us know, you know, that this is, I'd love to hear about that, but let's do NES today. So we're going to worry about Risk 5 on another day. I can tell you this, getting GCC to compile RISC-V, there's a Linux kernel port, everything's working fine in RISC-V, so it's pretty decent architecture. And if you have the tiny, I use the tiny FPGA sometimes, which I don't know where I put it, but it's tiny. I lost it. I don't know. So if you use tiny FPGA, you can actually synthesize this on a chip using totally open source toolchain, and then you could use GCC, and you can compile for it as a target, and you have like everything good to go. There aren't really computers yet that you can get with, like, I mean, Sci5 has a RISC-V system, but so, and just to let you know, RISC-V is sort of, this isn't entirely fair, but it's kind of in the same sort of space as ARM architecture. So like, you're probably familiar with ARM from like the Arduino and some other systems out there, but like cell phones have made ARM very popular. But ARM is a licensed, they're a chipless fab. So they basically, they're a fabless chip maker. They make the instruction set, but they don't make any chips. So there's tons of versions of ARM architecture available. The nice thing about something like RISC-V is it costs, you know, it's totally free. And if you want to synthesize it, you're not paying any IP. And it's kind of a great, it was sort of aimed partially at education, but also partially at real world use. So that's sort of why I like it. Okay. And yeah, I'll just throw a quick wave here. All right. So right, where we're, oh, Zero to Hero, thank you for the follow. Zero to Hero Dev, thank you for the follow. Appreciate it. So yeah, let's get back. I can't believe that just worked. That's ridiculous. I don't know how I feel about that. I was really digging in, expecting some trouble there. Okay, so let's show something that we want to see for debug purposes. So the current sprite location, let's start with like the sprite Y location. So this is Bitboi's location. Hey. Wow, look at that. On-screen debugging. Yeah, RISC-V has only 47 instructions, and on top of that, you don't even need a bunch of them. Like, I have my list that I crossed off. Like you don't need like any of the multiprocessor instructions if you're dealing with a single heart. Heart is RISC-V terminology for hardware thread. So if you have only a single core kind of machine, then you don't need any of the synchronization or atomics. Oh yeah, it's a pretty well developed ecosystem. It's a very interesting ecosystem, and it's something that I want to do shows on in the future. So I have no doubt that's coming. But anyway, yeah, look at that. Just shocked. We can. Wow. I didn't win any points on efficiency here, but you know, for just getting something to work, that's pretty sweet. So instead of doing 184, let's actually use the tile width of the NES, which is 30. So we'll go a tile over and say 29 times 8. Now that's a constant, so the compiler is going to take care of that for us, so we don't have to worry about that math happening on every loop. But yeah, okay, so I'm a little bit off. Oh, sorry, it's 32 across. So 32 across would put it off the screen. Yeah, so that's one off the screen. So we're going to draw that at 31, starting at 31 and coming back. Okay, so there you go. There's our counter. And I've got the, wow, sweet. Man, I should have done that the other night, Cam, when we were trying to figure out what was in memory all the time. That would have been way easier. Just if I'd known it was like 4 lines of code, 5 lines of code, I would have just done that. Like, okay, well, whatever. We got through our stream the other day. First on-screen debugging for Bitboi. Thank you. So cool. Are you able to add color? You want color on the sprite? I mean, yeah, we can color it, but so that, like, colors, okay, I can't easily change the color in the sprite. What I can do is I can set the palette that the sprite is using. And that's, I think that, I want to say that's the next parameter that I was ignoring on OAM sprite. Now, OAM sprite comes from Shiru's lib. So this is nestlib, and OAM sprite is, so here's the actual assembly for OAM sprite. And it takes, yeah, so this is the character number. This is the position in the character ROM. So when I show that, that's kind of like if I come over here and I pull up the PPU viewer, this is the character ROM here, right? So this is the, when I was showing you the NES cartridge before, the character ROM is typically another chip. Yeah, so this is the program ROM. So this is where my program's running, and this chip over here, this is the character ROM. And this is the battery backup for your saves. So the character ROM is being shown here is kind of what I have up here. And so I'm drawing digits from this scene. Now you'll notice they're not colored here because I did color Bitboi by setting the palette and choosing the different palette colors. But I didn't color any of these in their native. So if we want to if we want to kind of color them on the fly, we would have to sort of play some palette games. Are you able to shift from night to day? That would be cool. Sun rises and falls. Yeah, all right. I'm not actually trying to add features, Quadrant. This is the game was already built by the other streamer, 88-Bit Music. And so what I'm doing is I'm just porting it to the NES. I'm not trying to add features to it. So you cannot run it all on one chip. Typically, no, the reason they're not on one chip is because you're actually getting DMA. So this is the NES has an early GPU in it called a PPU. And these lines down here, these, so let me go bigger for that so that you can probably see it a little better. But this is the hard gold connector. It's not usually actually gold, but and these lines have direct address lines to each of these chips, like to the care ROM and to the this is the prog ROM and the care ROM, and this prog ROM is directly accessible to the PPU versus the care ROM, which is directly accessible to the CPU, and this can be loaded sort of sideways into the CPU as well. So that means that this doesn't need to wait for your program to execute. Your program can just set up like a DMA type transaction. Say, I want you to load the character like 74 and display it on the screen here. And the CPU doesn't need to be involved in that. It just sets that up to the PPU, and the PPU says, oh, okay, I'll just pull it out of these lines over here instead of these lines over here. So you can run both sides of the bus at the same time. So it's a huge performance improvement not to have them on a single chip. These days when you have a connector like USB-C, I mean, you can run gigabits through that thing. You can run video through that thing. So it doesn't matter as much. But, before we had high speed things like universal serial bus, we actually wanted parallel bus access, so this chip can be accessed directly. This chip can be accessed directly. The support chips are not. This is the memory mapper chip here. This is the MMC1. So this allows you to kind of play some bank games here if you want a little bit more memory. But anyway, I don't want to go too into like NES construction. It's a deep topic. But anyway, yeah, I mean, I could play a little bit with the palette. That's sort of what this attribute is here. And you can see that the attribute is, so this is pulling the parameters off the stack, right? So they're taking stuff and loading it in an OEM, right? And then they're writing to the OEM hardware. So it'd be easier if we looked at the OEM NestDev OEM sprite. So NestDev is a great wiki. So this is the PPU OEM. This is the sprite hardware in the Nintendo. And this is basically describing how you set up this write. Now, this library already sets the write up for us, so we don't have to actually do that. But yeah, there's the palette call on the attributes. So in the attributes tag, which is this parameter here, I can actually mess with the palette if I play around with bits 4 to 7. So that's here. Did I take too many? Yeah, no, that's right. So I have unimplemented, priority 0, flip the sprite. These two will be involved for flipping the sprite. So we can, let's try that out just for fun. So I can specify this as a binary word. So that should be a full 8-bit write. Now we want to, let's see, is that 1000? Okay, I'm a little bit off. There we go. So this will set the top bit, which is flipping the sprite vertically. So we can see if this is implemented. I haven't tried this, so this might be a little bit of fun. Well, I think I'm That might not do what I think it does. Oh, I'm totally editing the wrong line. Okay, so we're going to put that back to where it was. And we're going to go here and mess with the right one, which is this 0 over here. So we're going to say 1, 2, 3, 4, 1, 2, 3, 4. Okay, so if we flip this bit, then yeah, there we go, upside down. Oh, sorry, my bad, Cam. I just realized. I basically, fortunately, I edited the wrong thing. So if I close this, what I had was I was sort of messing around with the shot, which was I was editing the shot line, which yeah, here it is. This is the line that I was editing, and that's totally the wrong line, and I was messing around with this. So I ended up coming up here to the one that we just wrote, which was display score, and you can see this binary field over here. And actually, let me just roll this over to the next line. So you can see this binary field over here, and I just flipped vertical, and that's what just turned that score upside down. Yes, thank you, Quadrant. I had a little bit of fun with that. So NES has signed and unsigned binary numbers. The funny thing about signed and unsigned is that it's really just a programmer construction. So the whole thing about data types is a fiction, right? That's just your compiler conventions, and like it's telling your compiler kind of what to do. The bits, aside from some carry flags and like negative test kind of things, instructions, depends on the architecture you're on, they have very little meaning to the hardware. Sometimes it matters if you have like a hardware divide or some advanced math on your ALU, but generally speaking, it doesn't matter in this case. So T-Yo Flow, what's up? Interesting. Yeah, thanks. Yeah, it's good to know. So that's really more of like compiler convention. We always forget about like we think of the memory as like this is an int and this is a char and this is an unsigned char. Actually, it's just if it's a char or an unsigned char, it's just 8 bits. The only difference is the convention around whether that top bit has some sign meaning or not. So much more relaxed. I feel more laid back already. Don't the data types basically tell the compiler that I need X amount of space to store this value? Yeah, they do. And they also tell the CAM, they mention semantics to the rest of the compiler. Like this thing should be treated for math operations, or this thing, some of these things have meaning. Like when you're doing a printf specifier, which we don't get to do on a Nintendo. I just had to build my printf like my D, my %D specifier, which is kind of like a toy. What's that? A toy. Yeah, convert a string to an integer. So it's kind of the other way that I'm talking about, which is str to D. And this will convert, except not floating point, right? So maybe this one. I don't use these very often, so I always have to like kind of look them up. Unsigned long integer. So basically, what we did was we're doing the reverse sort of operation. We have a string. Well, actually, we have a number, and we want to turn it into a string because we're taking off a digit at a time, and then we're printing it out on output, and we're doing our own special output management. So. No printf. Yeah, there's definitely no printf here. we don't get a printf. I mean, unless you want to implement a printf, but printf is a pretty involved function. I was like trying to explain this on the C learning session the other day to Jesse. It's like there's a lot of stuff going on with printf. It takes variadic input, so you can have variable numbers of arguments. Printf used to stress out C quite a lot. Oh, I'm getting late in the day. I can't keep drinking coffee. What am I doing? No coffee. So, go away. Be gone, coffee demon. All right. So I do love the coffee. All right. So T-Yo Flow, thank you for the follow. I appreciate it. You welcome to the community. I just drank a cup, probably won't sleep tonight. That's what I'm worried about, Cam. That's exactly what I'm worried about. Okay, so, right, what are we doing? Well, we got our display to work. We even figured out how to turn our display upside down, which we don't want to do. And that, let's undo that. Let's play with some of this though while we've got it up. So this is our, yeah, there's our horizontal flip. See, that's hardware's handling that, which is pretty sweet. I know that's not impressive knowing modern GPUs, but it was kind of a big deal back in the day. So that's our flip vertical, and that was our flip horizontal. Priority, I'm not worried about. This is, you can use this for the Mario trick of like walking behind a mountain, you know, for stuff. Unimplemented is unimplemented. And then here's your palette changes. So 4 to 7 is, yeah, 7, 6, 5, 4. Yeah, so it's the bottom nibble. There's a term you don't hear much anymore. A nibble is half a byte. So, yeah, let's just one this up. Now, I don't think I've set that. Yeah, see, I haven't really done anything with the sprite hardware, like with the palette stuff. So we'd need to like define a palette, and you know, this is telling it like which palette to take for the character. And okay, so I do have some palette entry in there. So you can see that one just grayed. I don't know what's loaded on the palette right now, but actually, you know, I'll bet there's probably a debug for that. Yeah, here's the palette address. So I actually set this up previously when I loaded my palette in the first place. And that was a while ago, so I don't really remember what I did with that palette. See if I named it. Yeah, okay. I did name it palette. Sweet. So what was it? NT palette? NT palette, okay. NT palette. That's in data. So, okay, here's my palette. And this is the, so you can see I went really far setting up my other palettes. So this is my sprite palette. I set this up for Bitboi. So we could actually mess with that a little bit. It's nice to have a little bit of fun. So let's just comment that real fast. And so you need the NES colored map to know the, there's a NES colors. This is the palette right here. Okay, so let's take like 5, 19, 24, and 21. Okay, so this is palette entry 2. And that, hey, all right. There you go, Quadrant. So I left it up again. Damn it. I'm gonna stop loading the care viewer. Yeah, that's a nice blue. I dig that blue. It's a very, oh, here's a good word. Cerulean blue. Cerulean. Looks like the sky. So it's a nice sky blue. I like it. It's a very pleasant blue. We're gonna remember that palette like Pokemon. Haven't played much Pokemon, so I can't really tell you. So if we want to get like silly with this, no, let's not get silly with it. This is This is going to get us into enough trouble. Okay, so that, my guess here, yeah, that doesn't change it. Okay, so we've only loaded that last bit, because if I set this, well, I can't set it to 2 because it's binary. All right, so if I set it to 10, then this should go back to the other palette, which we didn't define. So we need to go and edit the data. I'm going to close this so that we're on one screen here. And we can actually set ourselves another palette to kind of mess with. Like if I put this here, and I kill this, and I run that, then yeah, okay, so that's still my blue because I copied it, and I can change these values so that, let's make that like 25. Yeah, and we get that pink. Or we could take like 2A here. Okay, yeah, there's like a nice green. It's very, I was obsessed for basically my entire childhood. Nice Squadron. That is very aesthetically pleasing. I love the way Pokemon was designed. Wish I would have been into Game Boy Pokemon games as a kid. Yeah, same as me, Cam. I just wasn't. I was busy playing the greatest video game of all time, Chrono Trigger. That's right. Prove me wrong. Chrono Trigger, greatest game ever. So collecting the card. Yeah, that's, I mean, it got into a whole collectible card game, and then that's what got me into emulators. Chrono Trigger is what got me into emulators. So Game Boy, not that I would ever emulate Chrono Trigger because that's not allowed, but I just thought, you know, out of academic curiosity that the Super Nintendo was engaging platform architecturally, and obviously I was only interested in instruction sets and, you know, things of that sort. Okay, so now it's all servers and clouds. Yeah, servers and clouds, that's different. I never played Chrono Trigger. Yes, that is the greatest game ever, Quadrant. Okay, never played it. Don't play. I mean, I'm not going to ban you, Cam. I'm just going to tell you to go play it. Send me an address and I'll send you a game. Okay. No, don't send me an address. It's really, the funny thing about Chrono Trigger is it's one of the few games in history that went up in value from when it was launched. Like the cost, even on like used, like you can't get an actual Chrono Trigger cartridge for, like, it's expensive. Yeah, I should play that. We are young. I did play the version that they had in Steam. They had a great sale, and I was like, you got to be kidding me! Chrono Trigger for like $1 or something. Like I'm in. Like I don't understand how that happened. I'll just take a look. Chrono Trigger. How is Chrono Trigger not age appropriate? It was definitely all audiences. Like what? So Kingdom Hearts is the same group, basically. Like that's Square and a lot of the same similar developers that built that for Disney. You know, they I could be mixing these up, but I want to say that was the same kind of teams. Yeah, they are totally addictive. Final Fantasy was great. Chrono Trigger was better. I'm sorry, and I say that as like Final Fantasy 14 was my main game for years. Like, but Chrono Trigger's better. I don't know what to tell you. It's just better. So, okay, I'll tell you no more about that. You can all enjoy Chrono Trigger as you wish. So, yeah, I never played WoW, so can't really comment. I've heard it just sucks your life away, so I'm afraid to even look at it. All right, so right, we know how to change colors. Yeah, that happened to me on Final Fantasy also. They're like, you're just a dirty casual. Well, We'll be talking about Final Fantasy 14 soon enough. I didn't have internet until I was an adult, so no WoW for me either. Yeah. I mostly code, then like 1 or 2 times a month play WoW. Nice. Well, hey, I mean, if you hit a balance with it, that's cool. Cam, I feel like at some point we should just talk about how to build internet, because you can add internet if you don't have internet. There's always ways to add internet. Occasional dial-up here and there. Yeah, we can just... I mean, we just got to get into... And, you're a radio guy, too. So, like, walk-fi... You can do some serious long-range Wi-Fi with walk-fi. I mean, that you want to, like, extend some internet. That's a lot of gain with one of these antennas. Like, so yeah. Cam's in the U.S. I actually had a few projects where, so I used to work at an ISP. I mean, so building the internet, this was like one of those things where I had dial-up. Connecticut is where I am right now and where I grew up. Connecticut's very not broadband heavy. It's gotten better. But when I was a kid, like broadband it was a long time before broadband came to the area. And Connecticut's kind of a strange place because it wasn't one of the Bell operating territories from like the original AT&T. Like all telephone companies were AT&T, and then AT&T got broken up, and then you got the Bells, the operating the RBox, the regional Bell operating companies, which was Bell Atlantic, Bell Pacific, whatever, all the different Bells, Bell South, eventually they all start consolidating back together. But while all of this is happening, and and then cable companies start acting as phone companies and start competing on broadband, none of that happened in Connecticut. Like that was all like, I want broadband. Can I get broadband? I want broadband. And so that was like the New York brethren, just like 20, 30, 40 miles away. Like they were getting like gigabits, and I was like pushing dial up. And anyway, like, so it was one of those things, like my dad was like, hey, you want to make the internet faster? Like go work for an ISP. And so that's, what I did. And so that's okay. I'm going to shut that off. Sorry about that. I just got Comcast recently at a gigabit. Nice. That's awesome. Not the Comcast part, but the gigabit's awesome. My life changed. Yeah, that's life changing. I mean, I started an LLC to do a WISP a few years ago, purchased a little equipment, and switched to a well-paying, time-consuming job. So eventually, that's a bummer, Cam. If you ever want to get back into that, I would be interested. That's ISP work, and that part of the country, like, there's no real radio issues. So but anyway, that we should talk about that later. Okay, so I got this to work on an island. All right, so I don't know, should we go for, we got our color. I feel like that's amazing. I just didn't expect it. I don't know what to say. I mean, it's a little overkill on the 4 digits. I mean, considering we're only passing in like a char. Let's just fix that now, because I don't feel like debugging it. So we're gonna say this isn't an int. This is really just an unsigned char, and that should be a no-op. And because it's not big enough for that, we should just be able to do this with 3 digits. And I'm just going to close this and make this. Yeah, there we go. Okay, so there's our 3-digit counter, and it's cool. Nice. So it's also starting to look like that video that Cam mentioned where the dude loaded like Flappy Bird in Super Mario, and he used the coin counter as the display. So I feel like we're debugging with the coin counter. I always wondered, I'm a mere mortal as an entry-level engineer. Hey, everyone's on the road somewhere, Quadrant. You start off somewhere. I mean, it's engineering like inventing. I mean, like, necessity is the mother of invention. So, like, growing up in a place that was broadband challenged, I got really good with, like, wide area links and conserving bandwidth and compression and everything that's related to like, you know, kind of bandwidth starved childhood. So I wish I'd have taken my networking degree more seriously and got more into BGP, OSPF, and other routing protocols. Very interesting stuff. Yeah, it is. BGP is still very useful. OSPF, still vendor neutral. Like when I got into it, it was a lot of EIGRP. I was doing mostly Cisco gear. So anyway, sorry, I'm going on a ramble there. We can talk about networking. I'm very interested in the internet and extending it everywhere. Okay, so this, where do we want to take this? I mean, we could wrap here. I mean, I feel like we're getting past the coffee part of the day, so we could either wrap here, or we could go, I don't know. I don't really want to get into the collision detector right now. It seems like another stream, so why don't we just wrap here? All right, fine. So we can ramble, we can chat. Switch the stream to just chatting. So, yeah, I mean, and this is also why Bitboi is taking so long to program. It's like one tiny little feature and then wait a little while, and then one tiny little feature and then wait a while. All right, so you know what? Maybe I should do one more feature. Yeah, what's like bite size? What's something we could do in a... No, distracting's good. It's Twitch. We're live streaming. You know what? It's more important we live stream. I mean, that I have a talk somewhere about putting it... I have no idea if I'll be able to find this or not, but it was about doing wide area networking on an island using walk-fi type techniques. Yeah, you know what? That's a whole other... I feel like the next thing on the NES is pretty big. Like, so for example, generalizing collision and adding jump physics. Those aren't small topics. So I feel like if we start that, then I'm going into like an 8-hour session. So I feel like this is not a good time to start that. So let's just say, yeah, is it here? No, I have no idea. I'd have to go dig it up. But yeah, basically, I mean, internet's like such a important thing. I mean, especially in our world as tech people, and we're all on Twitch, so obviously we're biased, but there's such a like it's one of those things I've always wanted to see like get better, and connectivity seems to have really crawled in terms of speeding up in the US. It's like we were so out in front on deployment and getting, you know, cutting edge technology and being fast bandwidth wise and everything else, and then everything just kind of like fell into a money grab. It was like that national fiber to the door project, and then all this funding was taken by the RBox, and then none of the fiber actually, they're like, oh, it's expensive, and then they just pocketed all the dollars, and so we all paid as taxpayers for bandwidth we never got, and then that gets into a whole world of like regulatory nonsense, and it's just how hard it's become to build decent internet speed. Like, why is that a fight? Like, it's such a ridiculous monopolistic game. But anyway, I don't want to get into that. Yeah, that was part of it was, and I've been paying universal access surcharges for years on my telecom bills, and I feel like none of that actually got to rural America deployment and like actually wiring up broadband. It's kind of terrible. But yeah, you know what? We should all do some network engineering projects and wire some stuff up. That would be crazy if we all just started climbing poles and throwing fiber up there. But we could dig up dirt, put fire. No. All right. So yeah, all right. Let's just wrap it for today. I got to finish up that website that I sneak peeked, that you can sneak peek if you go and take a look at the Coding with Some Guy link. So that is still a little work in progress, but at least I figure like release early, release often. So that will be getting better over the next like week or so. And I apologize right now for the mobile version, which is totally non-existent. So you're just going to get the desktop version on mobile for the template, but we'll do something about that later. So no, I don't want to put a link because it's too early. Just wait for it. I'll do a general announcement with that a little bit later, Quadrant. I have to do my Calc 2 homework for tomorrow. Learning Calc 1 is going to be my first. Yes, that is very important, Cam. You got to mind your derivatives. Yeah, that stuff's all fun. But yeah, so for those of you just tuning in, feel free to drop by. I'm gonna wrap up for today, but we're gonna finish this NES game. Drop by the Discord. I've got the show schedule and everything else there. And hello, Willa Cruz. That's a nice name. Yeah, we're gonna do a little bit of physics, and we're not gonna do calculus on the NES. But as we can see, the NES makes a pretty fine terminal when we start writing out numbers. So I guess the simple thing we could do is, as long as we started it, we still have some more sprites we could burn in that line. So I feel like we could do that, which is, yeah, what the heck, right? So no, it's bad. Okay, yeah, we're not going to do that. Yeah, this is about a real NES, WLA Cruz. So this is the EEPROM. This is the care ROM. This is the prog ROM for the game that you're seeing get built up here. This game. Oh, we have a command. We have a bot command now. This is Bitboi Classic. So I'm building this for 88-bit music. I'm porting a game that he built in GameMaker Studio over to the NES, and we're going to put that on real hardware and ship him a cartridge. So, and today we added a few colors, and we added this little coin display here in the top corner. So anyway, we'll come back to that. I'm heavy on this in the meantime. The next session on Tuesday night is going to be another learn session with Jessie. So we'll be doing, we're starting some project work. She wants to learn how to set up a C compiler toolchain. So we're going to spin up an EC2 instance and just set it up, and we're going to program on that for that session. So that'll be, we sort of finished the C as an additional language course, which for those of you who don't know, that is here. So this is C as an additional language, and we just finished the 14th session of that. So she's looking to like do some C work, not this kind of C, not NES CC65. This is not quite modern C because like you can't anyway. But using GCC. So we're gonna build that on an EC2 instance for the next session. So feel free to drop by for that. I'm watching High Score on Netflix. It remembers me that. That's cool. I used to work for Netflix. I was a performance engineer there. So this was a cup that I paid a price in blood for. This is my Netflix mug that I'm not allowed to drink the coffee because we're late in the day. So that I actually have that. So yeah, this was brief discussion of the kind of stuff I did over there, but I have heard High Score is good. I do want to check it out. That sounds like a pretty fun documentary. So anyway, thank you everybody for dropping by. Thank you for the follows. Thanks for hanging out. Thanks for NES coding, and thanks for the general talk, getting into the discussion. So we are going to peace out, and of course you can join us on Discord if you're not already there. So thank you everybody. Have a great day. Stay safe. Wash your hands. Get through this pandemic so we all live. All right. Take care. Bye.